This is CPM Calculus Chapter 2, number 100. So here we're given this. Let f of x equals to x squared minus 9 and g of x equal 2x squared minus 12x plus 18. We're asked to find all horizontal asymptotes, vertical asymptotes, and holes, if any, for y if it's f of x divided by g of x, and y if it's g of x divided by f of x. Okay, so let's start here, of course, and look at y is equal to f of x divided by g of x, and substituting in f of x we have x squared minus 9, and substituting g of x we have 2x squared minus 12x plus 18. Okay, so then let's quickly go over where horizontal asymptotes, vertical asymptotes, and holes exist. So first of all, in a graph, right, we have a vertical, or we have a horizontal asymptote, right? If as we're going in that direction, I mean as x approaches infinity or negative infinity, we get closer and closer to some horizontal line, but never cross it, right? So that's horizontal asymptote. A vertical asymptote is if we are approaching this point and we never cross it, right? If we're approaching this point, let's call it, I don't know, -2, and we never cross that vertical line, we have a vertical asymptote there. And a hole might be, well, our function just has an undefined point right here, right? So this is a hole, and this is our vertical asymptote. And these are horizontal asymptotes. Okay, so just getting an idea of what those are. So how do we find our horizontal asymptotes? Our horizontal asymptotes, if you can remember, is we are going to look at the numerator and denominator, and we're going to look at the highest power of x. Okay, so in the numerator or denominator, we're just looking at the highest power of x. So in the numerator we have x squared, right? That's the highest power of x. And the denominator, x squared, is here. We have 2x squared. Okay. If they're the same power, these are both to the squared, we just divide them and we get 1 over 2. Okay. And that makes us have a horizontal asymptote at y equals 1 over 2. Okay, so we have a horizontal asymptote at y equals 1/2. Okay, this is only true if the powers are equal to each other. Remember, just a side note, if, for example, our numerator over denominator, if we had x cubed over, I don't know, x as our biggest powers in the numerator of denominator, let's say this is 5 and this is, I don't know, whatever it is, it could be 1. This does not have no horizontal asymptote, okay? Because the power in the numerator is bigger than the power in the denominator, right? And if numerator over denominator, if we had the opposite, if we had x over 5x cubed, if the power is smaller, then we have a horizontal asymptote at y equals to 0. And we'll go and we'll learn about this more in depth because it has to do with the limits as x approaches infinity and x approaches negative infinity. So we'll look more into this later. But just know that if they're equal, the power is both 2. Then we look at the coefficients. We know there's a 1 in front of this x squared and a 2 is shown there. So it's equal to 1/2, and we have a horizontal asymptote at y equals 1/2. Okay, vertical asymptotes. So we have vertical asymptotes, remember, where our function is undefined. Well, kind of. Because we also have holes where our function is undefined, right? So we have to look at a couple of things. So first of all, vertical asymptotes and holes. So first of all, let's look at where our function is undefined, is where the denominator equals to 0, right? If the denominator equals to 0, then we have something divided by 0, undefined. So let's set that up. 2x squared minus 12x plus 18 equals to 0. Let's factor out a 2. Oops, I did not factor that well. 6x plus 9, right? Because we divide all the terms by 2. Okay, and then let's factor this. And we can use the quadratic formula. We can use the diamond method where we want numbers to multiply to get 3 and add to get, to multiply to get 9, and add to get negative 6. And that would be x minus 3, right? It's negative 3 and negative 3 times x minus 3. Okay? So we know this is true where x equals to 3 or x equals to 3, so we can just say x equals to 3. Okay, so we know this is this function, right here, undefined when x is equal to 3, undefined. So do we have a vertical asymptote or a hole there? Well, let's see if we can get rid of our holes, or sorry, let's see if we can figure this out. Okay, so let's look again at our function. We have y is equal to, I'm just copying from here, x squared minus 9 over 2x squared minus 12x plus 18. Okay, so let's factor and simplify this. We know in the numerator, x squared minus 9 is just the difference of two squares, so it's x plus 3 times x minus 3. And we factored the denominator there. We got 2 times x minus 3 times x minus 3, right? So we can simplify this and we get, these cancel out, we get x plus 3 divided by 2 times x minus 3, okay? So even after we simplify it, right, we simplified it. So this is simplifying. We still have the same issue where at x equals to 3, it's undefined, right? Y is undefined. So since after we simplified it, we still have undefined at x equals to 3, that means x equals to 3 is a vertical asymptote. So vertical asymptote x equals to 3. And because it's only undefined at x equals to 3, in both our unsimplified and our simplified versions, we have no additional holes, so no holes. Okay, so we have a horizontal asymptote at y is equal to 1/2 and a vertical asymptote at x equals to 3, and no holes. Okay, so that's part 1 right here, where y is f over x. So now let's look at when we look and have y equals to g over f. Okay, so instead of y is f over g, now y is g over f. Okay, so let's clear that away. And let's start by just plugging that in. So we substitute g of x is 2x squared minus 12x plus 18 over f of x is x squared minus 9. So first we're going to look at horizontal asymptotes. So remember, for that we look at the biggest power. Since they're the same, we just take the ratio. So we have a horizontal asymptote at y is equal to 2 over 1, right? Because that's an implicit invisible 1, which is y equals to 2. So we have horizontal asymptote at y equals 2. Vertical asymptotes and holes, we look at where it's undefined. Our function is undefined where the denominator is equal to 0. So x squared minus 9 is equal to 0. We can factor that as x plus 3, x minus 3, or we could use the quadratic equation, right? And then we get x is equal to negative 3 or x is equal to 3. Okay, so that's where we have our function undefined. Okay, so the next step is going to be can we simplify this? Well, the numerator we saw earlier is just 2 times x minus 3 times x minus 3, and the denominator is x plus 3 times x minus 3, right? We could cancel these out, so we're left with 2 times x minus 3 over x plus 3. Okay? So this shows us it's still undefined at x equals to negative 3. So since our function is undefined at x equals to negative 3, in both simplified and unsimplified, we have a vertical asymptote here. Just like earlier, we have a vertical asymptote at x equals to negative 3. But in our simplified version, we no longer have our function undefined at x equals to positive 3. So instead of a vertical asymptote there, we have a hole. Okay, so we have a hole at x equals to 3, and a vertical asymptote at x equals to negative 3, and a horizontal asymptote at y is equal to 2. Okay, you can find out, well, where is this hole exactly? Well, plug in x equals to 3, what's our output? So if we plug in x equals to 3, we get 2 times 3 minus 3, right, over 3 plus 3. I'm just plugging it into here. I know if I plug it into here, I'm going to get undefined. So I've used this one just to find out where the value would be if it was defined. So 3 minus 3 is 2 times 0 divided by 6, which is 0. So our hole is going to be at 3, comma, and our output of y is 0. Okay? Okay, so again, horizontal asymptote, vertical asymptote, hole. So at 3, comma 0, right here, our function has an open circle. Whatever it does on the left and the right, we're not drawing that, but we have an open circle, a hole, right at 3, comma 0. Okay, so this ends CPM Calculus Chapter 2, number 100.